Okay, so this is the first target question in the Math Counts Week 3 handout, and it says, if a ladybug walks on the segments of a diagram shown from point A to point B, moving only to the right or upward, how many distinct paths are possible? So basically, what does this mean? Well, we have a ladybug, right? And the ladybug can walk from point A to point B in any way, in any combination of paths, as long as the ladybug doesn't go left or down. So we could go like this, up and then right, or here, 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 because we're just going right and up. But we cannot go from here to up there to left to up. You got what I'm saying? Just have to keep moving in the direction of B. Okay, so how do we figure out how many paths are possible from A to B? Because there are so many. Okay, so let's think about it. If we go from A just straight right to this point, there is only one way to get to that point from A. You can only go right. You can't go up or right and then down because we're not allowed to go downwards. So there's only one way to get to this point. Similarly, there's only one way to get to this point because you can only get to points by going right or up, and there's nothing below these points to go up from, so you have to go right. Similarly, there's only one way to get to this point and one way to go to this point. We can do the same thing on this side. There's only one way to get to this point. You have to go up. And then only one way to get to this point. You just have to keep going up. You have to go twice. And then one way to get here, one way to go here. But what about this point right here? How many ways are there to go to that point? Well, you can go either right and then up, or you can go up and then right. So basically what we're saying is there's one way to get to this point and one way to get to this point. And you can get to this point from both of these points. So we're going to combine all the ways to get to the points before it in order to get this point. For example, we have 1 is directly to the left of it, and then 1 directly below it. So 1 plus 1 is 2, and there are 2 ways to get to this point. Well, now to get to this point, you can either go from the left or from down. So there's 2 ways to get there from the left. You could either go right, up, right, or you could go up, right, right. That's the 2 ways. And then there's one way to go from bottom. You have to go 1, 2, and then up. So we're just going to combine those ways. 2 plus 1 equals 3 to get to that ways to get to that point. Oops. And then we just keep doing this as we move on. To get to this point, well, it's going to be 3 plus 1 ways to get here. And then 4 plus 1 ways to get here. Well, what about how to get here? Well, this is just you can go from the left or from the bottom. So we just combine this 2 and this 1 to get 3 ways to get here. And we just repeat the same thing on the other side. And 3 plus 1 is 4. 4 plus 1 is 5. Over here we have 3 plus 3 is 6. Then we got 4 plus 6 is 10. 10 plus 5 is 15. Over here also 4 plus 6 is 10. Then 10 plus 5 is 15. 10 plus 10 is 20, and then 15 plus 20 is 35, and then 35 here as well. And then finally, for our last point B, there are 70 ways to get there. So the answer is 70. Now, that's one way to do it, and it works pretty well, especially if we have a small sort of area. We have to figure out how many points we can go from A to B. This is only a 5 dot by 5 dot grid. What if it's bigger? We don't want to have to write out all the different combinations. So what can we do instead? Well, if you think about this, how do you get from point A to point B? Regardless of what path you take, you're going to have to go right 4 times and then go up 4 times. It's just a different combination of rights and ups, right? You can either go right, up, right, up, right, up. But regardless of how you do this, you're still going right 4 times and you're still going up 4 times. So the amount of ways we can go from point A to B is just how many combinations of rights and ups can we use. Basically, just any way we can rearrange these motions is going to be the number of possible paths. So how do we do that? Well, for this, we use something called the choose function. So I have the choose function written there on the left in blue, and basically what it says is if we have a group of n different objects, and then k of them, in this case k is 2, there's 2 triangles, are the same type of object, and then the remaining are a different type of object, so in this case we have 3 circles, well then the amount of combinations of rearranging those different objects can be represented by n factorial over k factorial times n minus k factorial. So that might seem a little confusing, but I'm going to explain it in an example as we rearrange these arrows. So in this group, for example, we have a total number of n equals 8 different objects, okay? And so we have two groups, and one group, in this case k, has 4 different objects. And then the rest of the objects are all the same group, and there's n minus k of those, so all the remaining ones is just 8 minus 4, and there's 4 of these. So the amount of ways we can rearrange this is just 8 factorial over 4 factorial times 4 factorial. And if you don't know what a factorial is, it's basically just a number times all of the numbers that are 1 less than it. So for example, 5 factorial is equal to 5 times 4 times 3 times 2 times 1. So similarly, 8 factorial would be equal to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So, and then 4 factorial on the bottom is just 4 times 3 times 2 times 1. And then again, 4 times 3 times 2 times 1. And if you notice, the 4 factorials on the top and the bottom cancel out because we have 4, 3, 2, 1 here, 4, 3, 2, 1 on the bottom. And so we're left with 8 times 7 times 6 times 5 over 4 times 3 times 2 times 1. We still can cancel out some stuff. So 4 times 2 is equal to 8. And then 6 over 3 is equal to 2. And so this leaves us with a final answer of 7 times 2 times 5, which is equal to 70. So we did get the same answer, except this time all we really had to do was divide a few things. So, this might be more useful in scenarios when there are more combinations, but, both of these things work. So I just wanted to show you both.